All right, so we'll see if this works. I know it's weird. I know it's backwards. It doesn't show up. So if you go on the YouTubes, it actually looks forwards. You're better off watching it through the app on the phone, though. It's much easier on the Chromebook. It's going to look all like jacked. Okay? But you know what it is. You subscribe to it. All right. So why did we need to draw the Bohr model of the atom? Okay. So what you should be able to see, really, if you want to get complicated, is like, Cameron, you can see it. So, like, do you see the board on the phone? The image on the board on the phone? Is it frozen or? Yeah.
That's like that.
Okay, so you should be able to see the board through the line, but you guys also are seeing this, right, on your Chromebook. So that's important. So that's why. So the people that are missing can hopefully see it. Now, will Tyson Kester use this excuse to stay home the whole time? I hope he doesn't, because what this means is if he's watching on YouTube, that means the day he comes back, he has to make all the work. He must just come to school. Easy. Not picking on you, Tyson, for everybody. All right, look. Did you draw this? Well, okay. This is the Bohr model of the atom and it has 7 rings. Now, the reason why we want to draw this is because when you teach high school students about electrons, you want to use the Bohr model of the atom. Dante, it doesn't really look like this in real life, does it? No. Okay, was the Bohr model of the atom the correct version of it, or is there the modern version of it? The modern version is what we know it is, but the Bohr model is how you teach it, okay? The reason why you teach it is because it teaches about electron energy levels. Right? So now, if we go over here to the board, I'll get feedback if you do that. What's really going to blow your mind is if you go to the YouTube thing now and look at this, look at the infinity thing. All right, I want you guys to click on this thing. This is Bohr model. And you see a picture in your Chromebook, right? And those dots right there represent electrons, right? You may have learned this in biology at some point, briefly, right, Margaret? You put dots or you put electrons in the rings of the atom. That's the Bohr model, okay? All righty. Now, did we start this experiment last week where we looked through spectroscopes? Okay, the reason why we looked through spectroscopes and saw the rainbow was because that is what Bohr did to come up with the idea of energy levels in the atom. When you look at the rainbow, you guys see colors. Well, let me explain to you what the rainbow is. Click on this thing that says electromagnetic EMS spectrum. The rainbow is actually just part of everything in the universe. So if you guys look at a rainbow after a rainstorm, all you're seeing is just energy waves. Okay? You may not remember, but one of the people we learned about was Max Planck. Max Planck said that energy is frequency times wavelength. Max Planck's constant is energy times frequency. Look where it says visible. Look at that, Tyrone. It says visible right there, man. Visible light is only part of an entire electromagnetic spectrum of the universe. What's up, Dylan? You okay? So how come you guys can't see this other stuff? Can you see radio waves? No. Can you see microwaves? When you do a hot pocket, you can see the microwave oven. But, Margaret, can you see actual microwaves when they heat the hot pocket? When they heat the ramen noodles? No, you can't. Okay, can you guys see radar, like when the planes land? No, can't see that either. How about this? How about when you go to the doctor's office, right? You take an X-ray. Can you see the X-rays physically penetrate your body? No. What's that? So, why can't you see those? The answer is because you're not physically capable of it. When you go to the beach, all of a sudden you get tan, right? You get burnt. Well, you can't see the ultraviolet rays burning you. Honeybees can. You guys can't. Can you see body heat from little animals like squirrels and mice? Oh, you can? Oh my God! Well, just hunt at night then. I mean, you don't need anything. You don't need dogs. You don't need a spotlight. Just go out there in the woods at night and with a bow and arrow and just look on the ground like snakes do. Okay, so everybody except for Tristan cannot see body heat imagery. Body heat imagery is infrared. The only thing you're capable of seeing as a human is just a little slice physical. Okay, pretty cool. Let me show you what the world would look like if you could see it. If you could see all these spectrums, that's what the sun would look like. All of them. It would be multicolored. You would be able to see everything with the sun. Sunspots, coronal mass ejections, electromagnetic loops. It would look amazing. But you don't. You don't see that. Okay? Sun at different wavelengths. Well, that's what it looks like invisible. But here's all the other stuff. Let me ask you guys this. What color is the Wi-Fi coming out of the box up there? I don't know. What color is the Wi-Fi coming out of the box? Can you see it? No? I don't know. It's radio waves, guys. You can't see them. You know you're there because you're connected to the internet. You can't physically see them. Okay? The only thing you can physically see is energy from a wavelength of 400 to 700 nanometers. So if we click on this other thing that said, what is it? Electromagnetic spectrum in your Google Classroom here. Click on that thing. I added something, Anthony and Caitlin, to make more sense. Okay. So there's your colors. Now, when you guys look through the spectroscope on Thursday, Margaret, did you see numbers with them?
Yes.
Were they 4, 5, 6, and 7?
Yes.
So that goes with 400, 500, 600, 700 wavelengths of light. All you can see is Roy G. Biv. Roy G. Biv in reverse right there. You can't see near infrared, that's heat waves, Tristan. You can't see ultraviolet, that's suntan. And then you have stuff like microwave, TV, radio, X-rays, gamma rays. It's the same thing. That's the only thing you can see. Okay, does that make sense? Okay, so when we continue to look at this, when you guys look at 4, 5, 6, and 7, what those numbers mean are wavelengths of energy. You got it? Okay. So now go back to the assignment. Who has imported pictures into theirs? Did anybody import pictures? Probably, who did? Oh, yeah. She probably did. Well, let's look at this. Let's look at Riley's work. Riley. No, she may not have. You guys haven't turned it in yet. It's not complete. So, Riley, if you're listening, you have to do this. But anyway, you guys are supposed to take pictures of your phone, which is on the spectroscope. You're supposed to insert it. I think that is the better way to do it than drawing. Because drawing takes too long, Kaisha. Remember you had problems with the drawing tools? No, you don't remember? Okay. Come with me. All right, well. Oh my gosh. I'm having problems with the freaking USB. Okay, well, Riley drew it. Let me show you a better way to do this. Okay. Better way to do this would be the way Robert Barlow did it. Watch this. This is amazing. I'm sorry I didn't do this last week, but it just occurred to me on Friday. All right, so Rob took a picture through the spectroscope and then uploaded it. See? There's fluorescent light right there. Now, you guys see the numbers? 4, 5, 6, 7. What do they represent, class? Wavelengths of energy. It's the physical spectrum. Well, why isn't there a 3 over here, Diamond? You can't see that far. Why is there an 8? You can't see it. You're just humans. Okay, so you see the colors. The number 4 always has violets. Number 7 always has reds. Okay. There's hydrogen. There's helium. Notice that they're different. You got fluorescent light, you got regular light bulb. So now what you guys are going to do is I'm going to give you the spectroscopes again. Did we do helium and hydrogen? We did not. We're going to do helium and hydrogen today. We're also going to do the regular light bulb. The best way to do it, take your you look through the spectroscope, and you take your little phone camera, you line it up with the spectroscope, take a picture. Okay? Yes, that's the sound it makes. Yes. Yeah, just take a picture of that. Yeah. And import it. Okay, you guys ready? All righty. Practice. Just take your phone out and practice lining it up with the whole spectroscope there. Practice it. No, not yet.
You have 5 yours. You're too light.
Yeah.
Someone else push your face off. Then like you want to switch your face.
Okay. Just point at the lights, and practice taking pictures. Now, you've already done the fluorescent, or you should have. If you haven't, go ahead and get a picture of it. Okay, guess what? Guess what, y'all? Guess what? So, go. Just go back. I'm turning the lights out, so you're probably. Okay, y'all ready?
No way.
I wish I could use my phone on YouTube Live, but I can't because I don't have enough subscribers. You know that, Margaret? All right, you got to focus here. Okay, take your phone and take your spectroscope, the handheld thing that you look through, the spectroscope. You don't need your Chromebook yet, pal. Don't need your Chromebook yet, man. Okay, going in there. I'm going to show you where the hydrogen and the helium are. No. Come on, everybody. What we doing, Tyrone? What we doing, man? Cheating? No? You're not cheating. Okay, you see these lights over here? Gather around these tables. This table and this table. I'll give